Yes, we're live. Woo! Let's do some math. That's what I want to do because it's been a while. I want to talk about completing the square. We're going to spend probably a good chunk of day just going over the completing the square. Just get us back up to speed. That was sort of the last thing we did. And then if we have time, we're going to start talking about the new topic, which is modeling with quadratics. And I'm really excited because I feel like modeling with quadratics is the first time since you started learning math in preschool that we're actually doing something that math is designed for, which is mathematical modeling, which is looking at a situation and then coming up with a useful equation that we can then apply to the situation. So you're going to like that one. I will go out on a limb and issue a guarantee. But what we're going to do now is we're going to remind ourselves how to complete the square. And it will, thing one, remind us how to do it, but thing two, get our minds going to math again since it's been a while here. So let's look at an example. Y equals x squared plus 4x plus 5. And I'm going to go all the way back to the very beginning of complete the square. I'm not going to use the shortcuts. I'm going to walk through the process and basically going to just say, look, this is the concept. And then down the road, shortcuts galore. I mean, you don't have to do all this junk down the road, but to understand the idea, this is useful. So what we did is we said, well, let's take this x squared plus 4x and let's think algebra tiles. I've got a square tile that I call an x squared tile. And the reason I call it an x squared tile is because I label algebra tiles by the area of the tile, not the dimensions. This is an x by x tile that we call x squared. I have 4 x tiles. X tiles are 1 by x. And I have 4 of them. So if I'm going to make a square, I can put 2 of them on each side. And that gives me x plus 2. In fact, I want to put that in there. That gives me x plus 2 by x plus 2. Now, I do not have a square. I have to complete it. Because right now there's a big hole in the bottom of my square, in the bottom corner. And I know that that square is 2 by 2, which means that I need to put 4 unit tiles into that hole to fill it up. This square now has that area. I've also got 5 unit tiles sitting off to the side. You may remember I told you when we originally learned this that a lot of people teach this by saying, oh, well, take these 5 and then fill in as much as you can. I hate that. I hate it. Put it off to the side. Just put plus 5 off to the side and ignore it. But I also know that in order to make this a square, I had to add 4, which means that my equation is actually now out of balance because I added 4 to it. So I actually subtract 4 to keep it in balance. The green and the red cancel each other out. The green becomes part of the square. The red becomes part of my new equation. The red is just a balance. I can't write x plus 2 squared without sticking 4 in there, so I have to put a minus 4 on the outside to keep everything in balance. If I have to put a plus 4, I got to put a minus 4 with it. That make sense? You guys cool with that? Oh, but this was an equation, y equals when I started. So now I can simplify this as y equals x plus 2 squared plus 1 I want to no, that doesn't want to slide down anymore. Or maybe I just don't know how to slide it down. I'm a little worried about then messing up my camera setup as well. I'll make sure it's, I'll see if I can get it lower for next time. And I'll try not to write on the bottom half of the board. So now, what do I need to do? Last steps. I can now say that the vertex of this quadratic is at -2, 1. And I can, let's get this +5 down here, give me room. I can do a quick graph. I go -2, 1. And I know that my quadratic standard quick graph form is I go up 1 on each side, and then I go up 4 on each side. So here I run out of room. You know what? I want to do this right. I really want to do this right. 1, 2, 1, 2, 3, 4, 5, 6. There's my vertex at -2, 1. I go up 1, and symmetry says I go up 1 on the other side as well. And then I go up 4. So that's 1, 2, 3, 4. And symmetry says I do that on the other side as well. And boom, there's my quadratic. I am going to refer to this. This is something that I just started doing in my regular algebra 2. I refer to that as a quick graph because I don't need a calculator. I don't need to make a table. I just remember that 1 squared is 1, 2 squared is 4, 3 squared is 9, and I could just graph it as long as I know the vertex. That makes sense to everybody? We good with that? Okay. Guys, I will remind you of something since I haven't had any of you in class before. Please ask questions. I will never make fun of you. I will never tell you that that was a dumb question. I expect nobody else in my classes will make fun of you or say what a dumb question that was. There's nothing wrong with asking a question, even if you feel like, oh my gosh, everyone else is going to know the answer, because usually there's going to be somebody else who wanted to ask a question but didn't get around to it. And I'm happy to answer the questions. Also, when I ask you guys questions, it's okay to be wrong. I will make mistakes. There's nothing wrong with making mistakes. What we will then do is we'll figure out what the mistake was and what we need to do to correct it. So don't feel like, wow, I can't ask questions, or I'm really, really shooting for ask what you need to ask, and we'll figure it out, okay? Any questions about doing that? Okay, your turn. The equation is y equals x squared plus 10x minus 3. Please use completing the square to write it in vertex form. Write down the vertex, draw a quick graph. Go. square. 5 by 5 is yours. So if you got 10, how many go here and how many go there? Because you don't have a square, right? You've got a rectangle. But yeah, you have 5 on each side. There you go. Oh, I see. All right. Well, actually, do no question. How did we? Yeah, but look up the board. -3, right? Okay. -25 -3. Cool. Yeah, I didn't realize. Oh, what's that little? Just out of curiosity. How big is that little space right there? There you go. Sorry about the awkward vertex for the quick graph. Making an approximate quick graph. Because, yeah, that one's awfully. Oh. Okay, so where's when we go? So let's think about our equation. How big is this? Yeah. Because this bit right here is how long? Now this is that. So this is x by x. So how long is that one? Like, not multiplying, just adding. So we got x plus 5, y x plus 5. So this becomes x plus 5. By x plus 5. And then this becomes that. Okay? There's your equation. There's your equation. Get back. Uh-oh. How big is that green square? And how much is 5 by 5? Okay, let's see what we got. I don't have my stick set up yet. Thank you. Someone want to volunteer? Give me an equation in vertex form for this quadratic. Yeah. We good with that? Remember, 5 by 5 isn't 10. It's 5 times 5, which is 25. So that bottom corner, you're always multiplying. Somebody else, where's the vertex? Volunteer. Vertex. Yeah, Willem.
-5, 28.
-5, comma 28. We all agree with that? We do? We sure? Well, it would definitely be -28 because this is plus k. But it would also definitely be -5 because it's x minus h. So we have to put in a -5 to turn that into a +5. Does that make sense? And like I said, this is a super awkward one for graphing, but there's -5, comma -28. And so then I'm going to go up 1 on each side, and then I'm going to go up 4 on each side, and then I'm going to go up 9 on each side, and it looks something like that. And I don't particularly want to have to do a nice graph because 28 is too far down. All right. We cool with that? Any questions about any of the steps that got us to x plus 5 squared minus 28 or got us a vertex of negative 5 comma negative 28? Yeah.
Why is it negative 28 again?
Because remember that the standard formula of our equation is x minus h squared plus k. And to have a minus 28 in the equation, I have to be adding a negative 28.
How did you get negative 28?
So when I built the square, I had a, whoops, 5 by 5.
Yeah.
So that's minus 25 that I have to compensate. And then I had a minus 3 in the equation, and so then that gives me negative 28. Okay? Remember, we're always subtracting on the outside, 100% of the time. We're going to have to put a positive in here because we're multiplying these things together. So it doesn't matter if they're positive or negative. I'm adding something in here to fill the square, and then I have to subtract that on the outside to compensate. Cool? Okay. So I'm going to erase my example. I'll leave that over there for just a second, because now I want to do a different example. Slightly more complicated, because that's how we roll. My new example is y equals x squared minus 7x minus 3. So the process exactly the same. Here we go. I'm going to do algebra tiles. There's my x squared. It has dimensions x by x. I'm splitting my tiles in half to make a square, half on this side, half on that side. Oh, ew. It's an odd number. What do? Oh, I just split it in half. I can split odd numbers in half. 1, 2, 3 and a half. Notice that those are minus now because my tiles are negative x tiles. And on the other side, 1, 2, 3 and a half. Let's turn this into a square. We'll draw our little square right there. Now, how big is my square? It is negative 3.5 by negative 3.5. Oh, cool. It's still going to be positive because a negative times a negative. And because in elementary school I learned my times tables, I know that 35 squared is 1,225. Which means that 3.5 squared must be 12.25. Did you guys realize that because you knew your times tables, you could also square or multiply decimals just as easily? I didn't actually learn the 35 times tables, in case you're wondering. But over the years, I have memorized a lot of the perfect squares because they show up all the time. And so like 15 squared is 225. Useful thing to know. Pops up all the time. 35 squared, 1225. Pops up all the time. So, I mean, in your math class. I'm not saying in real life. So, what do I need to do? I need to subtract 12.25 to keep this in balance. And I will bring my minus 3 down from up there. And my equation becomes y equals My square is x minus 3.5. On the outside, I have minus 15.25. My vertex is at positive 3.5 comma negative 15.25. And my quick graph looks like this. Now you're thinking, what? But here's the thing. Even though it's decimal, it's really not that much harder. 3.5 negative 15.25 is right there. And of course, I really have a grid on here. So there's 3, and there's 4, and there's 2, and there's 1, and there's 5, and there's 15. And there's 14. Well, what does quick graph do? Quick graph says go out 1, up 1. So if I go to 2.5 and 4.5, I'm going to go to 14.25. And quick graph says 2 squared is 4. So if I go to here, I'm going to go to 11.25. Well, where's that? 14, 13, 12, 11. Oh, it's right there. Guys, notice how the process is just as easy. It's just that the numbers are a little bit harder. But you're still going 1 and 1, 2 and 4, 3 and 9. I could do more, but you know what? I'm not gonna. Hey, look, I have a beautiful graph of this quadratic. And it only took a few minutes because it's a nice straightforward process. Cool. Questions? Your turn. Y equals x squared minus 9x plus 6. Go. By the way, I don't expect you guys to know all of the squares. You're more than welcome to use a calculator to calculate. Be aware that there's a pattern, though. Because once you realize there's a pattern, life gets a lot easier. Uh-oh. You have 18 x times. Wait, you won't be giving me one. What do you got to do? There you go. And honestly, I don't know what is it? It's 2025. I'm going to commit that to memory, and then I'll know more. Way to use your read list. 2025. You got it. You got it. Yeah, don't forget if you're adding in here, you're always subtracting. Yeah, you can do that.
I just wrote that book through.
Oh, gotcha, just so you have the number.
Yeah.
You can sketch the quick graph. Because they're getting harder and harder as the numbers get more and more awkward. Really? Really?
Yeah.
20, negative 20 plus 6. Pretty good.
I'm lazy.
I'd say it's lazier to go for the calculator than you just take 6 off the phone. The same amount of work you have to do to get a calculator coming on and the numbers. Give it minus, so you can have minus 4.5. And that'll still be plus because, you know, negative because it's negative. Minus 4.5. Yeah, this won't be this how big is that square? Not 4.5 plus 4.5, 4.5, right? So yeah, multiply, yeah. Somebody hasn't volunteered yet, want to volunteer me an equation? All right.
Y equals x minus 4.5 squared minus 14.25.
Roberta, vertex?
4.5 comma negative 14.25.
Boom. I'll make a quick side comment, tangent. You guys are in honors, so I assume that means that you either like math or you're good at math. You're thinking maybe doing something mathematical. Start to get used to not always grabbing for a calculator for simple stuff. There's nothing wrong with grabbing a calculator for square and 4.5. But when you got negative, you got some number and you're adding or subtracting a small whole number, negative 20.25 plus 6. At some point, you're going to get to a situation where people are going to sort of look at you sideways and go, "Why does he always grab for a calculator? Why can't she do that in her head?" And so, start to learn the little tricks. Look at the whole numbers. Decimal's not going to change, right? So when you look at that, you say, "Oh, well, the difference between 20 and 6 is 14." Don't automatically grab for a calculator, because what happens when you always grab for a calculator is you don't start to develop that number sense in your head. And if you don't have a number sense in your head, you're not going to see patterns. Makes it, no, I won't say not, makes it a lot harder to see patterns. And if you don't see patterns, you won't be good at math. Math is about these patterns, and it's really important you start to develop that number sense. And I know they don't really work on getting you to develop a number sense in the elementary and middle school math, and I wish they spent more time doing it. But it's helpful to yourself to just start thinking about these things and just saying, "Oh, I know that one," and being able to jump straight to them. And first, it'll take a little bit more effort, but just, keep that in mind. All right, questions about this? All right. What happens after it gets slightly more complicated? It gets even slightly more complicated than that. The good news is there's only 3 total levels of complication. So what's the next level of complication? we're going to add a stretch factor. Here we go. Y equals 3x squared plus 10x minus 6. So I'm going to build a square. Don't write this down. Don't write this down because then you're just going to have to erase it. I've got 3 of these x squared, so I'm going to put an x squared on either side. And then I got 10 x's, so I'm going to put 1, 2, 3, 4, 5 x's down here. And I'm going to put 1, 2, 3, 4, 5 x's over here. And I got 2x plus 5. No, I don't. Yeah, I do. I got 2x plus 5 there. And I've got 2x plus 5 here. And I need to fill in this in order to make this work. Okay, so that's x squared. This is 5x, this is 5x, and this is 25. Anyone see a problem? I now have to write this as 2x plus 5 squared minus x squared minus 10x minus 25, and then I'll bring down my 6, but I'll leave that in blue.
Wouldn't the 2x be squared?
No, because this is a length.
Okay.
The whole thing, that whole length, it's 2x plus 5 by 2x plus 5, my big square. I can do that. That is a square. I have completed the square. My equation is now y equals 2x plus 5 squared minus x squared minus 10x minus 31. And that is the biggest useless piece of garbage I've ever written on a board in a math class. Because that doesn't tell me anything. The whole point of completing the square was to get it in vertex form, agreed? Hey, guess what? It's not in vertex form. There's all these extra x squareds and x's floating around. It's useless. There's nothing I can do with that. Even though, hey, guess what? It's another way to write the original equation, but it doesn't tell me anything. So I just wasted, how long? 3 minutes to write a new equation that didn't tell me anything. Why bother? 3 minutes I never get back. So what are we going to do instead? Here's what we're going to do instead. We're going to erase all this. And see, you didn't have to erase all of it. Aren't you happy that I warned you in advance?
Now you're gonna cry.
I'm not gonna. Are you kidding? I get well paid to stand up here and write useless garbage on the board. Here's what I'm going to do instead. I'm going to make a square, and I'm going to make another square, and I'm going to make a third square, because I know that I want parentheses x plus something, and now I get parentheses x plus something for each of these squares. How much am I going to put on each side? Well, I get 3 1/3. I get 10/3 per. See, it's a little complicated here, unfortunately. But each square is going to have 10/3 x's. So what I've really got is I've got 3 squares that each have an x squared plus a 10/3 x. Why 10/3 x? Because I'm divvying up the 10 squared or the 10 x tiles between 3 completely different squares. Now, what do I need to do on each square? I need to put half of that on each side. How much is half of 10/3? 5/3. So I'm no longer going to draw each individual tile, but I am going to say that that's x plus 5/3 and this is x plus 5/3. And this is where drawing the algebra tiles gets to be a bit of a pain and not worth the effort. Because it's now getting into fractions and weirdness, and at some point it becomes easier to just sort of do the algebraic process. But we're going to finish this out. Can we, you know what? I'm going to draw them. There we go. I got another one. X plus 5/3 by x plus 5/3. And I got a third one. X plus 5/3 by x plus 5/3. You know, it might have just been just as easy to write that I had 3 and draw one of them. But hey, what the heck? I've got them drawn now, right? So, how big is that square? That square is 5/3 squared. Except that I did it in the wrong color. That's supposed to be green because I'm adding in to fill the square, right? And there's a 5/3 squared. And here's a 5/3 squared. And then I need to subtract 5/3 squared from the first one. And I need to subtract 5/3 squared from the second one. And I need to subtract 5/3 squared from the third one. Whew. It's getting complicated. And what have I got here? Well, I've got x plus 5/3 squared. You ready for a shortcut? I totally want a shortcut. Hey, I got 3 of these. So I don't have to write x plus 5/3 plus x plus 5/3 squared plus x plus 5/3 squared. I know, I look at that and I go, oh, look, I got 3 of them. And I am subtracting 5/3 squared. How many times? And I got a -6. Hey, look at that. That's in vertex form. X minus h plus k. But what else do I have? Stretch factor. So what I now have is and I'm going to write this up here for the benefit of people who are directly behind my computer screen. I've got y equals 3 parentheses x plus 5/3 squared. That's 25/9. Agreed? But I'm multiplying by 3, so it's actually 25/3. Yeah. So I've got minus 25/3 minus 18/3. I did a lot of mental math there, but because if I put it in my calculator, what's it going to do? Give me a decimal, and ugh. So what do I now know? I know that my vertex is at -5/3, which is right there. -43/3, which is down here somewhere. And when I do my quick graph, instead of going up 1, I go up how much? 3. Because I'm stretching this. So I go up faster. And instead of going up 4, I go up how much? Times 3. 12. And instead of going up 9, I go up how much? 27. At which point now I'm up here somewhere. Because I'm just multiplying instead of 1, 4, 9, 3, 12, 27. Because I'm multiplying everything by 3. Now, what's the easy way to do this if I don't want to have to draw all of these rectangles, because it very quickly became a pain in the neck. Y equals 3x squared plus 10x minus 6. Here's the quick way. Ignore the 6. Factor out the 3. This becomes x squared plus 10 thirds x. So far, that's just what I wrote there. Okay? Complete the square. Y equals 3 times, well, now I'm going to complete the square. X plus half of that squared minus that little square right there, minus 6. This is always half. This is always just half. And this is always the same number squared. This is the half squared. Because once I factor out the 3, this is just a normal, uncomplicated, complete the square. And now I can distribute the 3 back in there and say, well, then therefore y equals 3 times the parentheses minus 3 times the half squared. And now I'm just simplifying. We cool with that? If you still feel more comfortable drawing the squares, I got no problem with that. Whatever strategy works best for you. But here's how I would draw the squares. I would draw them once. And just remember that I got 3 of them. There's your square, there's your completing the square, there's your compensating for completing the square, but I got to remember to do it 3 times. I don't have to draw 3 sets of algebra tiles, because drawing 3 sets of algebra tiles is pain. It's annoying, and it takes up a lot of space, and it's pointless to serve any purpose, because they're all exactly the same. That's why they invented photocopy machines. I want you to make 100 identical flyers. Now, you can get 100 pieces of paper and draw the flyer 100 times. But we don't have to. We've got photocopy machines. We have 3 times. All right? Cool with that? Your turn. Y equals 2x squared. See how I made your lives nice? Minus 7x plus 2. Go ahead and complete the square. Find the vertex. Do a quick math. So you're going to take half of that, but then you have to take a half for each square, right? Because remember, divide by 2 is the same as multiply by a half, so 7 halves. So here's the problem that I see. If this square has 7 x's, what's left for the other square? You've used all 7 of your x's, and you still haven't checked them. So you gotta have it again, because you're making 2 squares. So I'm gonna say the same. Uh-oh, wait, you got a lot of squares there. So think about this. X minus 3.5 means you got 3.5 on each side, right? Which means you need 7 x tiles to make that one square. That doesn't make 2 squares. Because now you really use 14 x tiles to make 2 squares over that. So you gotta split it in half before you start building your square, and then split it in half again to build your square. So this is one square, right? And that's fine, that's all you want to do. But in reality, you actually have 2 of them to create. You use 7 x tiles to make that one square. Do you have any left? Which means really, if you're going to make 2 squares, you need 2. Yeah. I would guess not, because, well, overall you will, yes, because then this one is 1.75. And then when you square your 1.75, you get less than that. So, I would recalculate, because now I don't know for sure. So let's think about what we're doing. If I was only making 1 square, I would put 3.5 each side, but I want to make 2 squares. So if you think about this out as a variable, it becomes 2 times x squared minus 3.5x. Now when I make my 1 square, how much of that is going to go to each side? What's happening? 35. Oh, you did it the old crazy way. Right? So that's not 2x squared, right?
No.
Because if it was going to be 2x squared, we'd have to draw it like this, but then there's no way that's a square.
Yeah.
So what we're doing instead is we're saying, well, let's build 2 identical squares where each one is just plain old x squared, but we're going to build 2 of them.
Okay.
Now, if I've got 7 tiles, how much does each square get? Without looking at what we've written here, how much does each square get if I've got 7 tiles? I want to make 2 squares.
Divide.
Exactly. So this is what I have for each of my squares. Now, when I actually build my square, how much do I have for each side?
Be half of them.
Half of that. Yes. Okay. That seems small. But I could be wrong because I had a +2 there, so that's why, yes. Actually, it still seems small. Because if 1 square has 3.0575, how much does 2 squares have? Got to double both of those things, yeah. Square them on there, because otherwise it's not like that anymore. Uh-oh. Uh-oh.
decimal.
No, it doesn't look right. So what do we got?
So it's 1.
Yeah, I don't think. Why did you really do that all along multiplication? Why? So if this was 2000 BC in Egypt, I would say, and you were calculating the overflow of the Nile, I would say absolutely multiply that longhand because that's our only choice. No, calculators are our friends when it comes to that kind of crazy stuff. Hey, all right, everybody looking up front. I was just talking to Amory about multiplying because he was doing long multiplication. Guys, let me show you a trick. 7 divided by 2 equals 3.5. 3.5 divided by 2 is, well, 35 divided by 2 is 17 and a half, so that must be 1.75. 1.75 squared is 1.75 times 1.75. And that's complicated and awkward. Let me show you something else that's less complicated and awkward.
Did you just divide 35 by 2 and then with the decimal point?
Yes, I did. Pretty cool, huh? You can always do that. Decimal point, when you're multiplying and dividing, you can just completely ignore the decimal points and do your multiplying and dividing and then stick it back in again later. But let me show you something easier. 7 divided by 2 is 7 over 2. 7 over 2 divided by 2 is 7 over 2 times 1/2, because divided by 2 is the same as times 1/2, agreed? Which means that that's 7 over 4. 7 over 4 squared is 49/16. But I need that twice. 2 times 49/16 is 98/16. Is my answer just as good as your answer if you did it with decimals? Nothing wrong with fractions. But look how easy it is to square fractions and divide fractions by 2 or by 3, or to multiply fractions by 2 or by 3. I did this all in my head, and yes, I've been practicing, but I can't do this in my head. What's 175 times 175 quick? I don't know. Could I figure it out? Yeah. But now, if I wanted a decimal, I could say, okay, well, how many times does 16 go into 98? And I could just very quickly do 16s in my head. 16, 32, 64, 74, 80, 96, remainder 2. Oh, look, that's 6 and 2/16, which is 6 and an 8. And now I got a number I can work with on a graph. And the complicatedest part was figuring out how many 16s were in 98. And by the way, you're almost always allowed to use a calculator to do those too. So if you want to do them in decimals, grab yourself a calculator and don't sit there and multiply 1.75 times 1.75. You're going to make mistakes. It's too easy to make a mistake, and it takes you 5 minutes to do the calculation, and now you're out of time, and blah, blah, blah. So there you go. Little tricks. Okay, I'm going to say, because we're almost out of time, that this is y equals 2 times x minus 1.75 all squared. And then somebody's going to tell me what goes here. Anybody? What goes here? Nobody wants to share? You make me do it in my head? Well, wait. 6 1/8 plus negative 6 1/8 plus 2. Fine. Negative 4.125. Am I right? Oh, sure. Now you know the answer. Couldn't have said it before and saved me all the effort. I happen to know, by the way, that 1/8, and this is because my other job is I am a Harley Davidson mechanic. Those are the same thing. Use that all the time when you're doing measurements, because 1/8 of an inch, 1/4 of an inch, 3/8 of an inch, 5/8 of an inch, 30 seconds of an inch. They're all based on that same little scale. In fact, one of the reasons that we divide inches into 32 is because it's a really easy calculation to get any little fraction of inches that you want. So, there you go. All right, one last thing. Omri reminded me of this. Guys, I have a 0 cell phone in my classroom policy. Here's what you have to just remember. Just pretend it's 1995 before cell phones were invented. I want them often in your bags before you walk in, and don't get them out until after you walk out, okay? They're a distraction. We don't need the distraction. I want us to be totally focused, and I don't want things buzzing in our pockets. And mine is generally turned off on my desk. If you hear it, you may think bad thoughts about me. All right, guys, have an awesome day. We will see you tomorrow. No homework.
Yeah.
Thank you.
Yeah, you betcha.
Thank you.
You're welcome.
I don't need to wipe the seats or anything.
Yeah.
Okay. Thank you.
They're going to come and clean it tonight anyway, so.